Hello awesome people, this is Jude from Awesome LCG. Today we will be talking about glass, more specifically how to model and render glass and liquid so we can get the most accurate result. First we will be covering a bit about the physical aspects of the interaction between light, glass and liquids, and then we will dive into each rendering. Like we'll start with Arnold, then we'll go to Vray, and then we'll go to Renderman. I'm going to include all the timestamps in the info section, so you don't have to scrub through the whole video to find whatever you're looking for. Let's wrap our head around IOR. IOR means the index of refraction. Let's talk about a single light ray. This is a single light ray. This yellow color line is single light. And as it goes through air, it doesn't do any changes to the ray. It just goes through it. It enters the glass. So at this interaction point, it changes its angle and it travels through glass. And when it changes from glass to water, the angle changes again. So each of these substances, air, glass and water, has its own index of refraction, meaning each has its own way of bending the light as it travels through the object. Let's say air. Air doesn't do anything to the light, it just lets it travel through. And glass, it changed the direction of the light slightly. The IOR is decided upon the density of the object. If you take an example, air is not dense at all, so it doesn't do any changes. Glass is pretty dense, so it changes the angle a bit. Diamond is a very dense material, so it bends the light the most compared to air, glass or water. One of the hardest things to do when we are rendering glass or CG refractive object is to get this interaction of light correctly. In order to make sure that we get the most accurate results, we have to make sure that we model the object properly. Let's look at some reference first. This is a picture of a glass of water. It looks pretty simple. We can't really see the edge of the glass or the thickness of the glass. It almost feels like the water is coming right to the edge. There's no separation between the glass and the water right here. When it comes to CG, it's very hard for the render engine to decide how this interaction happens if we didn't model it correctly. When we are modeling for refractive objects, we have to make sure to check on few things. The first thing is the normals. Think of this as a glass, and if we are modeling this, we have to make sure that this glass has its normals facing the right direction. So if this is the glass surface, the normals should be facing this way and the interior normal should be facing this way. So it has to be facing the right direction to begin. Then the next one, if we get the liquid needs to have the same kind of thing going on. It needs to have the normals facing this way and this way. When it comes to adding liquids into a glass, we have few options. We have shrink, which means we have a little gap between the liquid and the glass, and we have coincide, which means we have the liquid and the glass edges lining up with each other perfect, and overlap. In overlap, what we have is we have the liquids and we have the glass, and we have overlap between those two. Let's see shrink. In shrink, it has an air gap between the glass and the liquid. So if we do this in Maya, this is our test scene. We have a little softbox, a gray background, few objects, and an empty glass. We don't have any liquids inside. In a slightly side note, check how all these objects has a different look at them. Even though they have the same material, this one looks like a very thin material. This one looks like a solid glass ball, and this one looks like a fish ball. The little edge on the top. So that's why it's important to model them correctly based on what you want to achieve. This is just a sphere without anything. All the normals are facing outside. This one is a sphere, but I exclude the sphere outside. So you have two spheres like that. So you have a sphere and then I exclude it. And now I have another sphere. But what you have to note in here is that these two objects, these two surfaces are not connected with faces or vertexes. They are the same object, but they are separate. That's why they look like a thin surface. And this is modeled as a fishball. So let's add some liquid onto this guy using this shrink method. So we are going to have a liquid, but it's going to be slightly smaller. Let's see how it looks in our render. Okay, if you zoom into the glass, you can see that there's an edge right here. There's an edge, and there's an edge right here as well. So this is wrong. This doesn't match our reference at all. So if you model the object in shrink method where you have the glass, the liquid, and there's a small gap between them, it's not going to work. Let's talk about coincide. Coincide is when the glass and the liquid inside borders are aligning to each other. They match perfectly. Let's do that and see how it looks in our renderer. Okay, so this seems pretty good. You can see the edges are coming right to the edge. That's good. But if you look closely, there are a few problems here. You can see there are like triangles and weird artifacts happening. Like the ground looks totally different. There are some small air bubbles right here, and it took pretty long to render this one as well. So what's happening here is the renderer is trying to decide which object should come first, and it's thinking what the hell is going on. So we are just confusing the renderer. So this is wrong as well. We want it to be clean and beautiful. Let's try the overlapping method. So we have the glass and we have the liquid slightly overlapping onto the glass. The normals and everything are the same. Let's try that. It's already looking better and it renders much faster. This looks really good. It doesn't have any weirdness going on and the liquid is coming right to the edge. No weird black spots on the ground, no triangles, no dots, and it seems like this is the preferred method on all three renderers. So we won't be talking about anyone else today. We'll be just sticking to this guy, and now I'll be going to the three renderers. You can skip to whatever the renderer you like from here. Okay, let's get into rendering our glass scene in Arnold. So right now I have three lights in here, three area lights. It doesn't have any maps on it. It just have like colors, and I also have a dome. It's very important to have a dome when you're rendering things that are reflective and refractive, so we can get some reflection on our glass. Otherwise it's gonna look black, which is gonna make it unrealistic. When it comes to our glass, it's pretty simple. It doesn't have any special thing going on, and the liquid, as we talked in the previous section, we are overlapping liquid with the glass. So this is our liquid. It's overlapping with our glass. Let's make the shader. So to get the glass material, I'm just gonna assign a standard, and in that material I'm gonna get rid of the diffuse color and weight, and I'm gonna bring up specular color to all the way to white and weight to 1, and I'm gonna make sure I turn on fresnel because we need to make sure we have fresnel reflections. We'll go further down and we open the refractions and we bring up the IOR. For the glass we have IOR of 1.5. Whenever you need to find an IOR for a certain material, you can always Google IOR for whatever the material you are looking for. I will include a website that has IOR for all the materials in the info section, so you guys can reference it. And we have to make sure we turn on Fresnel uses IOR as well. That's all. I'm gonna assign the same shader, the glass AI glass shader, which I just created, on these three guys. The liquid, it's the same settings. The only thing that we're going to change is the refraction color and the IOR. Right now I have IOR set to 1.356. This is the IOR of water, I guess. Before we render glass and refractive things in Arnold, we have to make sure about a few things. We have to open the render settings for Arnold, and we have to go down to ray depth and make sure we have enough ray depth on diffuse, glossiness and reflection, so our rays goes through all the layers of our glass, like the liquid, the glass. As an example, we have few layers of glass here, because from here the ray goes in here and it has to go out from here, and then they have the liquid, so there's so many layers. So just to make sure we go through all of them, I just set to the total 12 and all these to 6. And just to make the quality a bit better, I put the camera to 3. So let's do a simple render of this guy. Let's open Arnold and render. You can see why we include the dome light in here. That's where we get all these nice reflections, these highlights. It helps a lot to sell whatever the rendering that we're doing. If they are reflective or refractive, the dome light helps a lot to create the nice reflections. Let's check out how we can do our beautiful glass renders in Vray. So as usual, we have our test scene here. We have 3 area lights. One of them is warm and cool one and just pop white one. We have a gray color background, and we also have a dome light to create all the nice reflections. Let's create the glass material. Select the object, we right click, assign new material, go to Vray material. And in the Vray material, turn the diffuse color to black and the diffuse amount to 0. Change the BRDF type to blend, reflection all the way up and amount all the way up. Turn on use fresnel, glossy fresnel, and lock fresnel IOR refraction. We're going to turn on trace reflections, put the max depth to 5. We are putting max depth to 5 so it can pass through all these layers from here and come out from here and go through the liquids, get up from the other side as well, so we can see what's inside. So anything above 5 would do the trick. In refractions, we're going to bring the refraction color all the way up and the amount to 1, and we're going to change the refraction IOR to 1.5. 1.5 is the IOR of glass. We assign the same glass material to these 3 guys as well. And the liquid, basically the same settings as the glass. The only thing that we're going to change is the refraction color. We're going to give it a slightly orange color just to see a difference, and we are going to change the IOR to 1.352. Let's do a test render. This is our nice render. We can see all these nice reflections coming up. All these are coming from the dome light. It really helps to have some kind of object be reflected when we are working with things like glass. It adds a lot more realistic feel to it. So that's all for the V-Ray. Let's get into Renderman. Okay, let's dig into the last one, which is the Renderman. So in Renderman, we have the identical scene. We have a gray background. We have 3 area light. Renderman, they are called rec lights, a dome light, which has the same HDRI map to it, the glass, and the 3 balls. So when it comes to creating the shader, we are going to a new material, the Pixar surface. We have to make sure our diffuse is 0, so the gain is 0, and the diffuse color is black. And we don't have to play with any of the particular tabs. If we go further down, we have something called glass. So we go to the glass tab. We bring up the refraction and reflection and the color to white, and if we go down to advanced, we can set up the refractive index to 0.5. And for the liquid, it's going to be the same material, but we are going to change the refraction color to a slightly orangish look, and we are going to change the refractive index, means the IOR, to 1.356, which is a liquid. Those are the shader settings. Let's go and check out the render settings. If we go to render settings, we have to check on few things. We have to go to sampling. And if you go down to integrator, we have the max path length. And if you go further down, we have something called the ray depth. So in Renderman, you can specify the specular depth and the diffuse depth separately. So just to make sure we have enough depth, we're going to put 8 in diffuse and specular. The max path length has to be more than the combination of these 2 numbers. So the combination is 16, so I'm going to put 17 here, just to be safe. In Renderman, we have another setting that we have to set up for each object. If we go to the shape node of the glass, and we have to go to attribute and Renderman to manage attributes, and we have to add 2 attributes, index of refraction and intersect priority attribute, and we add both of them, press close. And if you go down here, if you think about a glass and there's liquid inside it, the glass is the object that intersects the water or the liquid. So if you, as an example, if you pour water into the glass, the water will take the shape of the glass, not the other way around. So the glass has the first priority, 1 for the glass, and the index of refraction, which we put in the shader as well, we're going to put it to 1.5. And on the liquid, we do the same thing. We go to attributes, we go to Renderman, we say manage attributes, and we add the 2 attributes, index of refraction and intersect priority on them, intersection priority to 2, and we set the index of refraction to whatever we set in the shader, 1, 3, 5, 6. Okay, awesome. Let's do a test render. And yeah, it's done. We do have a less number of samples. The objects are clean, and we get all the beautiful things, and we get the nice reflections from our dome light, and everything looks awesome. That's all for this tutorial. And if you have any questions or confusions, if you couldn't understand something that I said, comment down below. Please like and subscribe my channel. And I'm really sorry about mispronouncing some of the words. My pronunciation is not the best thing. Cheers.